Hello again, folks. I had an awful lot of questions regards the loop and a lot of positive information as well. So I'm going to try and answer as many of the questions as I can. Now, these ranged from, there were a few things that I forgot to mention in the other video in part one, and that was how these loops are fed typically, okay? And there's lots and lots of different ways that you can feed these. And again, this is down to a little bit of experimentation on your part, because it's good fun trying to work out what will give you the best match to your radio and what will perform really well. And you can use something like Whisper. I mean, I love Whisper for that very reason. You can just, it's a really good medium for sort of testing the propagation of an antenna. It's a really, really neat thing. So what I'm going to do is I'll just, if I get rid of this, I was just trying to work out what it is I'm going to do. I think if I write in the corner here, basically one of the big questions was, someone left in the comments, how much of if you've got a modern day radio with this just say, I don't know, one of these, if you've got an SDR play or something like that, which gives you about 10 megs of cover of spectrum, how much of that spectrum can you expect to see with a Magloop? Well, the answer is very little. Yes, you will get a blue bar if you're looking at lots and lots of spectrum. But if you've got something with quite reasonably wide bandwidth or a lower Q, then you can expect to see just a smidge more. Is that right? Yeah, it's a slightly lower Q. You can actually you get just a little bit more in the way of spectrum. It doesn't fall off like a knife edge on either side. It's actually a fairly it's a fairly gradient. It's a gradient off to the edges. And something like a zero loop, you can actually see quite a bit either side. It's not actually chiseled. That makes them quite neat, those. Now that kind of brings me on to one thing I didn't mention in the other video was Q, or the quality factor of an antenna. In the case of the Magloop, they tend to have a very high Q and they're very, very narrow bandwidth. And I think off the top of my head that something like a Zero, which has got a fairly wide, because it's got a very it's got a large diameter tube, which normally equates to, if you've got a larger tube, you have a wider bandwidth very slightly. And I think there's a happy medium. And I've heard schools of thought sort of, I've actually read through, I mean, I can't tell you, I've got 4 books upstairs that are that thick, each one, which I've been wading through, and I've just downloaded heaps and heaps of information off the internet to try and make sure that what I'm trying to explain to you is as accurate as I can expect it to be. But again, I will remind you, I'm not an authority. I am learning. This is an experience that I'm learning, and just taking you guys along with me. But the way that I understand it, there is actually a happy medium, and that could be something like 38 mil. I mean, I really don't know, but Zero use about a 50 mil or a 60 mil tube. The loop that I've made, and I'll put a picture of it just here, that I made that out of sine pole, something called a sine pole system 80 or something like that. And that was about 60 or 70 mil diameter. It was all offcuts, which I welded together and actually made a big sort of hexagonal loop. It's quite a neat way of doing it, and it did give me a reasonable amount of bandwidth. Works very well, and that is what Q affects. It affects the amount of spectrum that you can see or whatever. But the thing is, it's not. It has a benefit, and the benefit is that it means that you can negotiate noise. So if you've got a very narrow queue and you've got a very noisy environment, you can actually null out the noise either side of that hotspot, if you like. And that is beneficial in some ways. However, there is a negative side to it. If that queue is too much, if that bandwidth is too restrictive, what that can do for you is then clip your TX signal, so you can take the edges off of your TX signal, and that is not something you want. So you've got to try and find that happy medium. And again, that's down to calculations, and the calculations and stuff for these Magloops is very, very complex. And fortunately, there are loads and loads of very helpful people out there that have put lots and lots of calculators and stuff up on the interweb. Now, some of them are better than others. I personally, I quite like some of the original DOS ones, because they actually they calculate some figures slightly more realistically than others. But there are a couple of really good like GUI type interface software available as well, which I'll put links to in the description. So then that kind of brings me on to what I didn't talk about, was how to feed one of these loop and what effect the feed point, or the way that you feed a loop, has on the radiation pattern. So let's go to the pad. So if we take, let's do it a bit orangey. If we take our loop and we do that, and let's put three loops. Now don't get excited, these are just loops. Right, let's take the most common ways of doing it. Now, a zero loop uses a delta match. There is another way of doing it with a double delta kind of match, which I'll do like that, and a ladder line. Okay. And there is the typical way that you do it with a just a normal Faraday type loop. There you go, come on. So yeah, so I'm making a pig's ear of that. Oh. Right, okay. So that is the way I see it is the three most typical ways of driving these loops. There is another way where if you take your loop and you quite simply do that. Now, I've used this way and it does work, but what I did was I will put I will put an image up here probably of my loop, how I did it. I quite simply used a dipole center down the bottom here. You know the sort of thing I mean. They're sort of sort of shaped like this. A couple of holes in it and a couple of studs poking up with threads. And that is an SO239. And all I did was I put my loop around the top of it like that, and then I fed it from just a made up lead, and it worked really well. But I did have to reshape it into the shape of like a teardrop, so it was more pointy than it was round. So let's get rid of that one. So what effect and how can you calculate some of these things? Now, there are lots and lots of calculations for these, and the calculations I'm about to give you are things that I've just picked up off the net. That they might be wrong, who knows, but they're worth a try, and that's what it's all about, and that's the fun of these sort of things. Bit of experimentation. This here, we'll call this dimension there, we'll call that big D. Okay, and we'll say that across all of them, and we'll call this dimension, if I can write, I've changed the nib on the pen. Right, okay, we'll call that little d. So we'll say little d equals big D over 10. Okay, and that will give you the rough length of that. And I think that I'm doing this from memory. Okay, it's been a long time since I've calculated these things, and I'm just recalling. So, if I'll double check and I'll try and put some links in there. But typically, that's how you do it on that side. Now we'll call this one here. We'll call that the length of that thing there. So we'll call it L. So we'll say L equals, and that is normally, I think it's the wavelength over 200. It seems to remind me of something. So there you go. So that equals, that will give you that dimension there. Now what I would do is I would use those dimensions to kind of experiment here as well. Now this type of loop feed point is used on the Bushcom, they're square loops. Now I'll put a picture of a Bushcom just here somewhere. He uses an adjustable delta match, and that's actually quite a good idea, because what you can do if you're feeding a loop with a delta match, trying to get the impedance or the the match just perfect can be really helped by having some adjustment here, because at the end of the day these are just they're just to get you close. They may or may not work for your particular loop environment, whatever. Bushcom in their loop, they use something like this with an adjustable thing, but on the top of their thing, they actually use a different type of capacitor instead of the typical kind of the typical sort of air type of capacitor. They use a tube with a piece of water pipe that's inserted in it, which then the whole lot then goes over the top of the main loop, and then it's actually got a locking pin on it, and the whole lot just slides backwards and forwards, and that gives you the tuning capacitance. There are a few joins in it, and like I said before, joins are bad. You don't want too many joins in it, and it especially goes, in fact the join on those loops especially is where the most current is. Now talking about current and voltage where it is on the loop, quickly, there was a really good video that was done by a young lady, Jerry Ellsworth, I think, off the top of my head. I will put a link in the description, because that is really worthwhile going over and having a little look. She made a really sweet little Magloop, tiny little one, and she demonstrated with LEDs and all sorts of things where the voltage was and where the current was. Really worthwhile going and have a little look. A link in the description. She's a real clever cookie, that one. So it's well worth a watch. Anyway, so people like Ciro and Bushcom, they use this sort of type of delta match. Sorry, maybe not this one, but they use a delta match. Now with this one here, we'll do a bit of blue. There you go. All right, this one here, because the delta match is over to one side, you get a very slight bias of radiation in that direction. Okay, there's no gain. Okay, there's no, loops don't tend to have gain. It's a miracle if they've got gain, because obviously they are inefficient. Where they win is their radiation pattern. That's kind of, and actually there's something about a loop that just seems to work in where others don't. But you get more radiation in the direction of the delta match. It's slightly reduced in this direction. Okay, it's I don't know by how much, but there is a slight benefit on this side, and that actually brings me on to another question very quickly. Was which direction do these which direction do they transmit in? Well, they are, when they are upright, okay, that is actually a horizontal radiation pattern, or whatever. And if you imagine it as, say, a hula hoop roll, if you roll a hula hoop in the direction that you want it to go, that is exactly how a loop works. It rolls in the direction that it's transmitting, and so this one will roll faster forward than it will backwards. I don't know any other way of putting it other than that. Anyway, so let's get our blue up there. Right, now then, this one has got the same delta matches here, okay? Now, except this one's fed with a ladder line. That might be a good way of doing it. What I can see this one having the benefit of doing it this way is that it will be even, it'll be sort of equal radiation pattern, or it'll be equal strength either side. So that's how I see that. One thing to bear in mind about delta matches, when you add a delta match, okay, it's a good way of feeding a loop. It's very robust, and it can withstand a lot of knocking about. That it adds inductance, and occasionally you may see someone they might put a capacitor in series with the feed point. And that normally nulls out the inductance, and that normally is a variable one, I believe. What I'll try and do is, again, if I can find any links to things, I'll put it in the description. It may take me a couple of days to accumulate all the links, but I'm going to try and get this video up today. Today's the 1st of January, 1st of January 2020. So happy New Year to everyone. Right, now then, so this one adds, in my opinion, it probably adds twice as much as inductance as this one. So here, obviously it's you're adding a delta loop at a given rate, and I would use these calculations to try and give you, the little d on both sides. So we'll call that D2 and D1. I would just use that just to see where it gets you. It might work, who knows? But you can make these adjustable anyway, so they get a little bit in and out. But that is the benefit you get from it, the fact that it will actually even Stevens transmit, in my opinion. All right. The other benefit with this, I think, is the fact that it's fed with a bit of ladder line. That's always nice if you can do that. However, there is some twist on this. You often find that they will feed this with a 1-to-1 Valen. Okay, and then that looks like a bit of coax. You'll often find they're fed something like that as well. Not sure how this one works. Never tried it. Again, if you want to try it, then happy days. It might be fun. So that's the benefit with that. So yeah, so I think we've covered that type of delta loop, that type of feed point, and there are lots of feed methods. More. There's tons of ways of doing this. Now, this one here is where you take the. Let's just zoom into this a little bit. This is where you take the inner of the one coax. Okay, you peel back a smidgen of the other coax, so you're exposing the braid. Okay, and then you solder the inner to the braid. Okay, and at that point here, and what that effectively does is kind of gives you a weird kind of loop, and all you do is you feed it on the end here. Now, types of loop that are fed like that, Alex loop, got the same sort of design around that. Alex loop, MFJ loops, if you remember the old Capco loops, they're fed like that. And benefits on this one, even Stevens. again, pretty even across the board. So there's no, fast side or slow side, if you like, or strong side or weak side, unlike this type. This one here this one here would benefit from a rotator, I think, possibly. As do they all to a degree, because obviously what you're rotating them for is not strictly direction, because they're 180 degrees. That is just nulling out the noise. So you can rotate them normally, just 45 or so degrees is enough to kind of null out noise. There is another way of feeding these as well, and this is the way that I've used in the past. And it's like I said earlier, I did that thing with the SO239 and actually did that. Again, it's even Stevens across the board. The blessing with this one is that it's just incredibly simple. It's not difficult to do at all. So what else we've done? The other one was the question I got asked was ground loss. Now, ground loss, unfortunately, is a bit out of my league when it comes to how this is all calculated. It's very, very complicated how they do this. I couldn't get to grips with it. But what I did read was, if you've got a loop that is, say, 1 meter, and I said earlier on that it was the school of thought is 1 to 2 loop heights off the ground level. That still stands. But I've kind of been, what I've gathered from the information is that once you start going below about a loop height, then the ground the ground loss increases to quite a level that becomes significant. Once you start going up above 1 meter to 1.5 meters, the ground loss starts to become less significant to the point of being insignificant. So there is a sweet spot with these loops, okay, that seems to matter. But again, I really don't know what that calculation, I don't understand that calculation. Again, and if anyone knows anything or has any information on these loops, that'd be really, really cool. In fact, actually, what I would love is for Callum, Dietz Commander, to actually maybe model one of these out, and just to sort of in all the different variants. That would be really sweet. Just to sort of see whether or not, what these things are doing, because very interesting, these things, and they work very well. They're not the best things in the world, but they just work. The other question that I got asked was on the type of loop with the fed with the standard sort of Faraday parasitic loop in there. Is there any advantage to having any adjustment up and down in that loop? The answer is yes. It can help you get the help you get the absolute sweet spot. Typically, they're taken right to the edge. I've seen loads of methods of sticking these on, from hot glue, from cable ties to basically plastic clips, to all sorts of things. I think that pretty much sums it all up. I hope that this has been of some benefit. And again, as I say, please leave comments below. Keep them respectful. I don't know everything. This is sort of something that this is a learning process for me as much as it is for anybody else, I'm sure. But what I will do as well, I'll tack on what I've built, what I've got photos of, to the end of this video, because it's actually quite interesting. I built all the capacitor. I had access then to quite a lot of machinery, and for those of you that don't know, I was involved for a long time with R&D in all sorts of things, but I was involved quite a lot with 3D design and 3D drawing and stuff like that. So, and AutoCAD and all sorts of things. So I had a lot of access to the machinery, like the water jets and the laser cutters and all that sort of stuff. So I then had quite a lot of the capacitor, which I made myself, just cut out and did all sorts, and it worked out really, really well. It was a very very sweet bit of kit, and a good friend of mine, Bill, he was G4 KKI, I think it was his call sign. I'll be very upset if I forget his call sign. He was a lovely, lovely fella. Just at a time when I was almost going to throw in the towel with ham radio, he really sort of tore me a new one and just sort of said, you know, don't give up. Not everyone is like that. And unfortunately, I met a core of people in ham radio that, let's just say that weren't particularly friendly to newcomers. And it really did put my nose out of joint, and I just thought, do you know what, I didn't want to know. But Bill was such a sweet guy, and unfortunately he is silent key now, and that is a great loss to everyone, because he was just such an influence on me with these Magloops and stuff. And back in 2006, you know, we were building these things and putting them all over the all over the country. I sent loads out all over the country to various places. It was just it was good fun, good times. So I mean, if you do a search on Google for 2E0TIG, you'll see Bill and his granddaughter putting these loops together, which was very special at the time, but is slowly disappearing because Bill has been dead now for probably 4 or 5 years, and you know, slowly as the accounts are starting to disappear and to be deleted, the information is sort of going. But you can see some of the photos and stuff like that. It's really, really, really sweet. So if you've just a little side note, if you've come across a situation where it's kind of put you off ham radio, don't give in, all right? Because not everyone is difficult. And there's plenty of people out there that will help, and that's really, really good. So have fun, and Happy New Year and all that sort of good stuff. And I hope that 2020 is going to be absolutely fabulous. And here's to the next video. See you soon.